Our second type of reaction is acid-base reactions. These involve transfer of a hydrogen ion, H+, from one chemical to another in the reaction. There are two parts to acid-base reactions, the acid and the base. Acids are defined as substances that can dissolve in water to make H3O+ ions. We have the special name for that ion, hydronium. An example of an acid is HCl, hydrochloric acid. When it dissolves in water, the H+ and the Cl- come apart from each other. The H+ combines with the water molecules to make H3O+, and the Cl- stays as Cl-, but it gets surrounded by water molecules. We end up with chloride ions that are surrounded with waters, and H+ are actually bonded to the water to make H3O+, which is hydronium. We can classify our acids based on whether they are strong or weak. Strong acids are going to completely dissolve in water. We're going to use the full right-facing arrow to indicate that the reaction goes to completion. After the strong acid dissolves, there are only going to be products remaining, so none of the original acid will be left in the solution. It will all be broken up into ions. Weak acids only partially dissolve. Let's say we put in 100 molecules of an acid. Maybe one of them will break up into ions, but the rest of them will stay stuck together. We're going to use half arrows to indicate that the reaction only goes part of the way. Some of the ions get broken apart, but not all of them. The reactants and products end up being in the final reaction mixture. We're not getting rid of all of the original stuck together acid and turning it all into ions. Instead, some of it stays stuck together and only a little bit of it might turn into ions. Examples of weak acids are citric acid, which is found in citrus fruits, and acetic acid, which is found in vinegar. The equation for the reaction of acetic acid with water is shown at the top of the slide. We can see the double half arrows are used to indicate that the reaction only goes partially. In fact, only 1% of the acetic acid molecules that get put into water turn into ions, and the rest stay in their whole form. How do we know whether an acid is going to be strong or weak? Basically, for you guys, you're just going to have to memorize it. We have this list of 7 strong acids that you need to memorize. 3 of them have a hydrogen along with a halogen from group 7A. Those 3 halogens are chlorine, bromine, and iodine. Notice that fluorine is not on this list, so HF would be weak. We also have some oxyacids. We've got nitric acid, chloric acid, perchloric acid, and sulfuric acid. It's not all oxyacids, only those specific 4. Memorize these 7 strong acids. Anything not on this list is going to be a weak acid. The acids on this list are going to dissociate completely. They will turn into H+ ions and then whatever anion it was with, like Cl- or Br- or NO3-. That's what's left in the solution when the reaction is finished. The weak acids, which are not on this list, are not going to dissociate completely. For bases, the definition that we're going to use is that it's a substance that will dissolve in water to make hydroxide ions. One of the most common bases is sodium hydroxide. We can see a picture of it on this slide. It's usually found in these little white pellets. Sodium hydroxide has been around for a really long time, so it has some historical names, such as lye and caustic soda. If you hear those names in a hardware store, for example, they're talking about sodium hydroxide. Bases have the same distinctions as acids between strong and weak. The strong bases are going to completely dissolve. We're going to use the full arrow to show the reaction is going to completion. Only the products are going to remain when the reaction is finished, and none of the whole base stuck together will be left at the end. Weak bases are only going to partially dissolve. We're going to use the half double arrows to indicate the reaction only goes part way. Both the reactants and the products are going to be in the beaker or flask at the end of the reaction. Some of the base will be stuck together, and some of it will be split apart into ions. Just like with our strong acids, with our strong bases, we're just going to memorize a list of them. There are 8 strong bases that you need to memorize. 5 of these have an element from group 1A along with the hydroxide ion. The other 3 of them have an element from group 2A along with hydroxide ions. Remember, these are going to be neutral overall. We have 1 hydroxide with each of our 1As, which have a +1 charge, and we have 2 hydroxides each with a -1 to balance out the +2 charge of the group 2A ions. Notice that for the 2As, it's only the ones lower down on the periodic table, the heavier ones. It's not the ones towards the beginning of the periodic table like magnesium, but the ones lower down than that. The most common weak base is the ammonia molecule, NH3. Ammonia is used in a variety of different ways, including making fertilizer and as a household cleaner.